Greetings everyone. So I'm going to talk about Radix sort. This is the second part actually. In the previous part I've explained some concepts in Radix sorting. So especially this slide I have explained. Please go and look at it. Right. So in this video I'm going to get to the algorithm of Radix sort. So first the algorithm identifies which is the largest number in the array that is being sorted, and it counts the number of digits in that. For example, if we have 256 as the largest element, then the number of digits in that are 3, which is 2, 5, and 6. Okay. In the next step, it sorts the numbers based on digits, starting from the least significant digit. Okay, so it looks at all the numbers and chooses initially the least significant digit, and then based just on that particular number, it will sort the numbers in increasing order, for example. Okay, once it does that, then that completes one pass. Then it moves to the next significant digit, starting from the previous significant digit to the least significant digit. Okay, for example, in 256, first it looks at 6, and then in the next pass it will look at 5, and then the final pass, third pass, it will look at 2. Okay, so that's how it works. Now, in the previous one, I've explained how this count is recorded in the bucket array. All right, so I'm going to fast forward over that. Now I'm going to tell you how it records the same array is used to record the positions from the beginning of the sorted array. For example, here we are saying that there are two numbers with least significant digit as zeros, for example 10 and 20. So we have 2 here. So we are saying that these two numbers, based on their least significant digit, will occupy 2 positions from the starting. So 10 would be here and maybe 20 would be here. So that is 2. The next bucket has one number, okay, which has a least significant digit as 1, which means this particular number. Now this will occupy the third position. Remember, the first 2 positions are already occupied by these 2. So the next available position for this number is third. So that's why we are saying 2 plus 1 equal to 3 here, which means that this digit with this least significant digit as 1 will occupy the third position from here. So 1, 2, and 3. So this 1 would probably occupy this third position, 1, 2, and third position. Okay. Now 3 positions are already occupied here. Okay, 2 by these 2 digits and 1 by. So the next number which has a least significant digit of 2. There's only one number with the least significant digit of 2, which is 12. So that would occupy the fourth position. Okay, so we are saying 3 plus 1 is 4, and we record 4 there, saying that this particular number with the least significant digit of 2, right here, this is 12, will occupy the fourth position, 1, 2, 3, and 4. The 3 positions before that are being occupied by 10, 20, and 1. Okay, and we keep going that there is no digit with least significant digit as 3, so we remain at the same position. Okay, but when we come to this number with the least significant digit as 5, for example this 25, that would occupy the 5th position, right? So because these positions are already occupied, so the only next available position for 25 is the 5th position. So 4th position is already occupied. So this one number will occupy the 5th position. So we say that is 5th position. Similarly, the last number which is least significant digit as 7, will occupy the 6th position because the 5 positions are already occupied by the remaining numbers. So this is going to be 6th position. So that's what this indicates. Now we will arrange these numbers based on this position starting from the last number. For example, if you have 1, right? So 1, the 1 is the least significant digit. So if we look at the bucket 1, we're saying that this will occupy the 3rd position from the right. Okay, so 1, 2, and 3. So this 1 will occupy this particular position. Okay, and remember we have reduced that by 1 because if there is another number with the same, it would be occupying the 2nd position, but we don't have that number. So okay, but anyway, so that's what this number indicates. Now let's look at 5. Then on bucket number 5 we have position 5, which means that 25 will occupy the 5th position from the starting. So 1, 2, 3, 4, and 5. So 25 would go to this position. Okay, and then again we reduce that by 1. Okay, now next we have 20. So 0. So 0 has position 2. Okay, all right, so it will occupy position 2, 1 and 2. So it will go here. Okay, that's 20. Now this 12 is the least significant digit of 2 will occupy the 4th position. Okay, so 1, 2, 3, and 4. So 12 would go there. 7, if you look at bucket number 7, so least significant is 7, bucket number is 7, that occupies the 6th position, which is pretty much the last position. 1, 2, 3, 6. So it will go over there. All right, and then finally 10, which has 0 as the least significant digit, will occupy the 1st position, which is here. Okay, so that's that. So we have completed the first phase of our sorting of first pass based on the least significant digit. Okay, so the numbers are, so if you look at the least significant digit, 0, 0, 1, 2, 5, and 7 are in increasing order. So just don't look at the complete number. Just look at this least significant digit, 0, 0, 1, 2, 5, and 7. If you really read those numbers, they are in increasing order, right? So that first phase is over. The second phase is it looks at the most significant digit. Remember, there are 2 digits. So we completed the least. Now we are looking at the most significant digit. Same, the bucket array records the number of occurrences. Okay. For example, here there are 2 numbers with the most significant digits being 0. Like you have 0 here and you have 0 here. So these 2 numbers go into bucket 0. Then you have most significant digit 1 with most significant digit of 1 having 2 numbers. For example, 10 has most significant digit 1 and 12 has most significant digit 1. So these are 2 numbers that go here. Similarly, the most significant digit with 2 are 2 numbers. So this 20 and 25 both have most significant digit as well. So they are 2 numbers. So recorded here. Remaining all will be zeros. So now we go back to determining the positions. So this 2 numbers will occupy 2 positions. Okay, all right. Then these 2 numbers will occupy the next 2 positions, and these 2 numbers will occupy the next 2 positions. So to calculate the positions, we add these 2 and record that as 4. So this will occupy the 4th position. Okay. These 2 numbers will occupy up to 6th position. Okay. 2. Then 3 and 4 are occupied by this most significant digits, and then 5 and 6 are occupied by the most significant digits being 2. Now we will sort these numbers. So anyway, those are all 6. So here if you go back, the most significant digit is 0. So if you look at that, its position is 2. So we will record it in the second position. Okay, reduce that by 1 so that the next number with the same will come into position 1 rather than 2. Okay, but anyway, this is 2 here. So that will go into position 6, the last position, and then we reduce that by 1 so that the next number will fit here. Okay. Now this one should be in the 4th position, 1, 2, 3, 4. Okay, so that will go into the 4th position, and then you reduce that by 1 so that the next one will fit into the 3rd position. Okay. Next, this is 0. This goes into position 1. Okay. 2, that goes into position 5. And of course, we reduce that by 1 once we. Then this 1 goes into position 3. Okay. All right. So this completes the algorithm. Now you see that there were only 2 digits, so there were 2 passes. Now you see that the numbers are all sorted: 1, 7, 10, 12, 20, and 25. Okay.